guys, I am Tiffany Sikintel, and today I'm going to give you a quick tutorial on how to master or learn some factoring techniques that we need to use in the algebra. Now, factoring is one of the most important skills that we need to learn in algebra, so answering math problems will be a lot less frustrating. If you can master factoring, you'll be able to understand and answer math problems a lot easier when you go to a calculus or trigonometry or higher algebra. Now, the factoring techniques I'm going to introduce to you today will be number 1, factoring by difference of two squares. Number 2, factoring using the greatest common. And number 3, factoring by grouping. These are the factoring techniques that I'm going to be discussing in this lesson. Now let's work on the first factoring technique, which is the easiest factoring technique to use because you only need to recognize the difference of two squares in a given polynomial. If you see a squared minus b squared to this pattern, you can factor it out or separate your polynomial into a minus b times a plus b. Now, to be able to understand factoring better, you really need to invest some time on how to master the timetable or the multiplication table, because if you can visualize the multiplication table rather easily, then factoring will not be that frustrating. Now, you will see that the perfect squares that I'm talking about here will be number 1, 4, 9, 16 up until 144. Which means if you take the square root of those numbers, it will give you an integer as an answer. So these are the sum of the perfect squares that you will see or encounter in this particular factoring technique. Now we have 3 examples of polynomials that fall under this category. So the problem 1, 2, and 3 matches in the pattern a squared minus b squared. We can separate this polynomial into this factor form. So 25 minus x squared can be simplified or can be separated into 5 plus x times 5 minus x, and t squared minus 64 can be factored out into t plus 8 times t minus 8. And the last problem we have is we can separate it as 4y squared minus 16 to 2x plus 4 and 2x minus 4. So this is how we use a technique in finding the difference or finding the factor form of the difference of two squares. So once again, you need to know your timetable to be able to recognize this pattern. So make sure that you know your multiplication table really well to be able to understand factoring a lot easier. Now the second factoring technique that we are going to use is the greatest common factor technique or the GCF technique. Now, before we use that factoring technique, let's first review on how to find the greatest common factor of a polynomial. So for example, we have 2x plus 4, and the greatest common factor of this polynomial will be equal to 2 because 2 is the greatest common factor can divide 2x and 4. So that's going to be the greatest common factor for the problem number 1. And for problem number 2, the greatest common factor is 2 for its coefficient of and x for its variable, because 2x can be 2x squared and 4x evenly. And for the last example, notice that in our coefficient, there is no common number that can divide 15 and 4, which means we'll only have the greatest common factor in the variable, and in this case, the greatest common factor is x squared. So from those 3 examples, we can find the greatest common factor of a given polynomial, which we're going to use in factoring using the greatest common factor. Now, let's use the same set of examples that we've used, and this time, we'll change it into its factored form. So let's define first what is factoring. So factoring is basically undoing or reversing the distributive property. So if you can reverse a distributive property, you basically factoring using the greatest common factor, which means if we have 2x plus 4 with the greatest common factor of 2, if we divide 2 and 2x to 2x and 4, our quotient will be simply x plus 2, which means the factored form of 2x plus 4 will be 2 times x plus 2. And if we multiply out to 2x plus 2 or use a distributive property, notice that it will still equal to 2x plus 4 because as I've mentioned before, factoring is simply undoing the distributive property. So if we're going to use a strategy to 2x squared plus 4x with the greatest common factor of 2x, if we divide 2x to 2x squared, you will left with x. And if you divide 2x plus 4x, you are left with 2. So the factor form of 2x squared plus 4x is simply 2x times x plus 2. And for the problem number 3, x squared will be outside on the parentheses and 15x plus 4 will be inside the parentheses because you have undone your distributive property in factoring using GCF. So that is how we use the greatest common factor for problems number 1, 2, and 3. Now let's discuss 2x squared plus 4x further, just to give you how we can use the greatest common factor in any polynomial that we will encounter in algebra. So the first thing that you need to do is to find the greatest common factor of the integer or the coefficient, and in this case, the greatest common factor of 2 and 4 is 2. And with the variable, the greatest common factor here will be x. So we always want to check the greatest common factor of integer or coefficient and the expression or the variable that we are working on. And once you have found the greatest common factor, just divide the common factor to 2x squared and 4x and you'll have the factor form of your polynomial. So that is how we factor using the greatest common factor. Now we're going to be working on a lesson on mastering factoring by grouping. So this is the last technique that I'm going to share to you guys. So this is also another factoring technique that we are going to be using in algebra. And in this particular example, notice that we'll have a few more terms in our polynomial so we can use this factoring technique. Let's say that our polynomial is y cubed plus 3y squared plus 4y plus 12. Now notice that there's no single factor that can divide each term in this polynomial. So when this happens, we'll use a factoring technique by grouping, which means we're going to separate each group into two sets. We'll have the first set, which is y cubed plus 3y squared, and the second set will be 4y plus 12. Since we have separated into two groups, now we can use another factoring technique, which is the factoring techniques that we just learned, which is we will factor out each group using its GCF. Now for the first group, the greatest common factor of the first group is y squared and the greatest common factor of the second group would be positive 4. Which means if we divide y cubed to 3y squared by y squared, will be left where the y plus 3 inside the parentheses. And for the second group, if we divide each term by positive 4, we will be left with y plus 3 in our parentheses. So now we have two sets of terms with the common factor of y plus 3. So notice that in our first group, we'll be able to produce y plus 3 as a factor, and the second group we're also able to produce y plus 3. Now in this case, we'll be able to use the factoring using GCF once again to be able to simplify our polynomial further. So by factoring by grouping, when you see several factoring techniques to be able to solve or to be able to separate our polynomial, so in this case, y plus 3 can be factored out outside the big group, and in the big parentheses, you will be left with y squared and 4. So the completed factored form of this polynomial using factoring by grouping will be y plus 3 times y squared plus 4. So this is how we use a factoring by grouping for polynomials similar to this one. In time, by exposing yourself to a lot of examples, you'll be able to do it better and a lot easier, because in mathematics, it's all about practicing and exposing yourself to a lot of problems to be able to understand the steps easily. So continue to work, continue to solve, and continue to live. I think that will be all. Thank you for watching this video. I hope you learned a lot. Thank you. God bless everyone.